Good afternoon, everybody. When Craig rang me up in November to ask for papers from Audubon Sugar Institute for this meeting, he said we really want somebody to talk about this unusual occurrence at the beginning of the season about crystal elongation. So here we are. We don't know exactly still what's caused it, but I do hope at the end of this presentation you're going to see that we've made a lot of progress into understanding it. And we don't want to just state the problem, we also want to find solutions for you. I'd just like to thank my co-authors. Alexa Triplett's been working really hard on the chemistry the last few weeks. Stephanie Imbachi, Ordonez, and Lengoro are the ones responsible for setting up the crystallization system at Audubon so we can carry on with this work. Okay, so presentation outline, what actually happened in early season. And then we're going to look at the study of elongated crystals from 5 Louisiana factories. Then the laboratory crystallization set up at Audubon so that we can reproduce these elongated crystals with syrups that we obtained from the factories and we have in storage. And then finally, conclusions and future work. So I think Harold just alluded to this. Very early in the season, we had these very elongated crystals, and you can see so elongated, difficult to even see which axes the crystals were growing on because they're so needle-like and elongated. And if we look at one more closely, where we did some measuring the elongation factor. You can see the ones that you're looking at here from Alma, they were actually 8-fold, 7.9-fold elongated, 8 times the normal elongation. And the minimum was 1.83, average was 4.64, and we had a variation of just 36%. So highly elongated. And what were the weather and factory conditions that were causing this? Well, first of all, it's the more we're having these longer crop seasons, and again, Harold alluded to that, we're starting earlier. We're starting in mid-September, so obviously it's more hot. And in this case, it was unusually dry and warm. Not all the factories had the problem, a lot did though, and those that did had slow pan boiling rates, and again, as Harold mentioned, some of them had slight centrifugation problems. So we went round to the factories and were asking questions, and one thing, they were all saying that their crush reduces had a low pH, 4.8 to 5.2, we normally get about 5.5. In Louisiana, and this is a very strong indicator of microbial deterioration. When you get microbes deteriorating, they form acids, and that was what decreases the pH. The other thing that was really interesting and unusual is the haze Dextran. So the haze Dextran is actually a misnomer. It's you add alcohol, you form a haze, and you measure the haze Dextran, but really you're measuring haze polysaccharides. But this was not elevated. So that kind of indicated that perhaps what was causing this was low molecular weight, smaller molecules that may be causing this. One factory, I asked them, have you noticed anything different? And they just said in the yard, they smelt some alcohol. Now, one factory in Louisiana has a HPLC system, so they can measure glucose and fructose, and that came in handy with this study because across that early season, when they were having this elongation, the glucose was higher than the fructose, and that's a strong indication of fructan. Fructan I've been mentioning the last few years in Louisiana here at ASSCT. That is long and short chains of fructose, whereas Dextran is actually made up of small, short and long chains of glucose. It's the opposite. So that was another indicator that Dextran wasn't causing this problem. And then early on, we noticed the molasses was containing a lot more fructan than normal, and I want to show you that here. So it wasn't till 2017 we realized that we'd underestimated fructan in Louisiana. So if you look at the green columns, that's 2017 ALMA, and in the yellows, the 2018. Notice that in 2017 and 18, they started the grinding season later, more early October. And so if you look at last year, 2022, when we had this elongated grain, you can see they started earlier. And notice those blue columns are much higher than what we had in 2017 and 18. So we knew we had elevated fructan. And you can see across those first 7 weeks, we tended to have higher fructan, but it did get better across the season. Now, we also I've added a couple more factories in 2022. I've added St. Mary because they had this elongation pretty bad, and then Sterling, who didn't have it so bad. But so the first thing I want you to notice is week 3 on the bottom here. If you look at week 3, so notice that all the factories, the Alma, Sterling, and St. Mary, Sterling's in orange, St. Mary's in gray, they all had higher fructan than in 2017 and 18, and so they were all a little elevated. And you can see in week 4 here that Sterling tended to have slightly less. And then we looked here at the Dextran. Now, this is antibody Dextran. In other words, it's specific to Dextran. We're definitely measuring Dextran with this method, but we're picking up low, medium, and molecular weight Dextran. But the first thing you can see is the ALMA 2017 and 18 in the green and the yellow. The Dextran in October in those 2 years was much higher than in 2022 in the blue. And also Sterling and St. Mary were lower as well. But notice Sterling had the higher Dextran, and that kind of tied in with what they were saying to us, that they weren't getting these elongated crystals as much as the others. So that there is an indication there of why. Now, are we totally surprised that we're picking up fructan and dextran in the same molasses? Not totally. Dr. Giovanna Aiuta from the Audubon Sugar Institute has done some very good work in the last few years. She's looked at microorganisms in crusher juice, and you can see here she's found a lot of different microorganisms. That isn't new. That has been known for a few years, about 30 years, that there's not just one microorganism forming dextran in crusher juice. But what was really a surprise was most of those bacteria, and at the bottom you've got Saccharomyces cerevisiae, which is yeast. All of them tended to also produce fructan as well. So we know that they can produce both, and they often produce both. What we don't know is, why do they switch? Why do they go maybe back and forth, producing dextran sometimes or fructan? Dr. Aiuta is working on that, and she's looked at some factory conditions that affect the production of fructan and dextran. Okay, so now we go to the study of the elongated crystals from 5 factories. You can see on the bottom row, we got 5 raw sugars from Alma, Lula, Rehisland, St. Mary, and Westfield, and we got a control that had the normal size. We actually washed all these sugars carefully because we wanted to wash the molasses layer off the crystals, because what was causing this elongation had to be in the crystal. You can see when we washed them, some of the colors went down. It is known, it's well known that some colors prefer the crystal over the molasses, so that wasn't new. And this is just a little diagram to show you what we did. Here's the raw sugar crystal here. It's got a slight molasses layer around it. We washed it with 66 pure sucrose solution, very gently mixing it. Then we washed it with methanol, saturated ethanol, and then isopropyl alcohol, and we ended up here with the washed crystal. The next thing we had to do, we had to put a number on this elongation. If we were going to try and find out what was causing it, we needed to compare it with certain chemical parameters. We needed a number. We used particle size analysis. But when we looked at these particle size graphs, we thought this isn't adding up, because some of them that were highly elongated had crystals shifted to the left, so it wasn't adding up. And we checked visually. Here's some micrographs of the washed crystals. You can see the control normal crystals, and all of them had elongated, particularly Alma. And then we realized, and Alma's in the green, it should have been much more to the right. We realized that what was happening in the machine, it was, they were so long, the crystals, they were breaking. So obviously that was that, we can't use particle size analysis to do this work. So we actually ended up doing it all by hand. I have to thank Stephanie for this. So we measured by hand the length and the width and divided it, and we got an elongation factor. And you can see all those crystals, non-washed crystals and washed crystals, all of them were had a higher elongation factor than the control. The control was 1.3. That's because sucrose crystals are not perfect squares. Sodium chloride crystals are perfect squares, but sucrose is a slight rectangle. Anyway, you can see Alma and Lula in particular had the worst elongated in these samples, just in these samples. When you washed it, the slight decrease in the elongation, which you'd expect. When we correlated the numbers from both the washed and the non-washed, we got a very good correlation. So we were very happy with this method, and we could use it and look at it and compare it with parameters, chemical parameters in the crystals. So here we have the fructan and the dextran in the non-washed and washed crystals. Fructan is in the green, dextran is in the blue. And I just want to say here, to be clear, the fructans were measured with a research enzymatic kit. It's very specific to fructans, but it's picking up small, medium, and large fructans. And again, the dextrans, we used Antibody kit. Again, it's picking up or detecting small, medium, and large dextrans. So the first thing we saw is here's the non-washed fructan, and then the washed, and all the elongated crystals had a lot more fructan in them. The fructan did not wash out anywhere near like the control. So in other words, more fructan was staying in those crystals. And then you can see here the dextran. Some of them had 0 dextran and others had negligible amounts. So this basically confirmed what we'd seen before. Dextran is not responsible for the early season elongation of crystals. We then looked at the percent fructan in the crystals versus the elongation factors, and we got quite good correlations. They're not perfect, but there's definitely a strong trend there. As the percent fructan in the crystal increased, the elongation factor increased in both the non-washed and the washed, particularly the non-washed, which is the ones that you're seeing. As I said before, the fructan, the way we measured fructan was given as just the total amount. We need to zoom in now. We need to use another technique. And so we're using ion chromatography, which gives us a lot more information about the small chain sugars in those samples. Unfortunately, our 2 ion chromatograph equipment, they were out of action, and we were begging the the people who sold them, to fix it, and luckily they fixed it about 3 weeks ago, so we've been able to zoom in. Here are some chromatographs of 7-brick solutions, and I say that because you can directly compare them. They're all at the same concentration. So here you've got the small sugars, the glucose and the fructose. Each peak represents a different compound, but we know as we go along the chromatograph, along the axes, the bigger the sugar. And then you have the disaccharide S, which is sucrose. And then we start to see trisaccharides, and then tetrasaccharides, and on and on. And you can see here we have quite a few oligosaccharides in the non-washed crystals, including the control in the black. And then we looked at the wash. We directly compared it with the wash. The first thing you can see is that some of these oligosaccharides or short-chain sugars were washed out. Some of them didn't exist in the wash crystal. And then when we looked at this peak here, if you look at this here, there's 2 actual peaks there. They're not totally separated. And we could see in the non-wash crystals that the control crystals didn't have that first peak here. And the other thing, when we washed the crystals, that peak still remained in all of the elongated crystals. So that was an indication. Obviously it wasn't washed out, it was still in the crystals. This could possibly be one of the factors causing elongation. So then we correlated the peak high. The peak high is basically an indication of the concentration of that peak, which is a compound, and we got very good correlations, nearly perfect with the non-washed crystals. So it looks like this may be one of the culprits causing elongation. But we still can't say for sure, because we have to identify it using LC-MS, mass spectrometry. We can also use specific enzymes. And then even then, I'm not going to say it's the culprit. We have to show that it actually causes elongation. And the other thing I want to add, there may be more than one peak. There may be more than one compound causing these problems. So I just want to put that out there. We also found a very good correlation between the fructan in the wash crystals and the peak height. Again, we have to confirm what this is. So obviously we have taken, and I want to thank all the factories. We've got a lot of barrels stored here, you can see. We've got barrels of syrup from many of the factories where they had elongated crystal problems. And we've set up, Len and Stephanie has set up a laboratory crystallization setup at Audubon, and they were actually able to replicate. So we're going to be doing a lot of studies from now on with the different syrups. And we have a lot to do. We have to look not only at why is it elongating? Which axis is it elongating? How is it affecting the crystallization rates? And we're never going to find solutions until we find out what's really causing it. But you can see here where they could reproduce the elongated crystals at Audubon. And I just want to say we did some early on enzyme tests to see if it could stop the elongation. But these enzymes are, first of all, we were really stabbing in the dark because we don't know totally exactly what it is. And we added it to syrup. These enzymes are hydrolases, so we need water, just like the dextranase that Harold was mentioning on. So we haven't given up on these enzymes, and we'll be carrying on this work in the next few months. So I hope you can all come to the Audubon Factory seminar on April the 19th. Conclusions: severe elongation occurred Looks like it's microbial deterioration due to the lower fructose glucose ratios, higher fructan in the molasses and low pH. You can't use particle size analysis to measure. You've got to use your hand measurements, or maybe there's another way. Dextran was confirmed not to be responsible. It looks like fructan may be involved. We have identified one peak, which we think is a tri or a tetrasaccharide, but we have to confirm that. And then we've got a laboratory system and lots of barrels of syrup to continue this work. So I want to thank you for listening. And I have one last thing to say. Jose Manuel Enrique is working at Audubon for a few months as an extension advisor, and he's going to have his conversation for fabrication superintendents, chief chemists, and instrumentation managers on the 21st of March in St. Gabriel, near here. And Giovanna Ait is going to actually talk to you a little workshop on microbial degradation and biocides and everything you need to know to maybe try and stop this from happening. So thank you. Any questions?
Thank you so much for your extensive work on this particular thing. Are we the first ones in the world
No.
that have this problem?
No, that's a good question. One of the reasons we zoomed in on the fructans was in South Africa about in the 80s. They found out that there was 3 oligosaccharides, they're called castoses, was causing it. Now, we don't know if it's the same elongation they got, but it was a possibility. So, but even then, I still can't say exactly. We don't have the scientific evidence still to say it's exactly what they've been getting. So we still have to keep an open mind.
I understand. And with this fructan being in the crystal itself, will this affect the refinery?
All I can say is that it's possible that the refinery's got elongated crystals. I can't really answer that. Harold? Yes? No, that's a good question. We know that there's a certain amount of castoses in the cane, so I'll call those plant oligosaccharides, right? But we also know that a lot of them form on microbial deterioration, and the evidence is pointing to microbial deterioration here. So we will, with this oligosaccharide, with the chromatograms, we hopefully can separate those two things. Yeah. And I'm sorry, it's more complicated than I hope it would be, but it is what it is. Thank you.